This lesson comes out of section 1.5, Velocity and Other Rates of Change. To start off this calculus lesson, it really makes sense to talk a tiny bit about, I guess, what you mostly would have learned in physics, or even in the Science 10 part of physics. Physics 20 would work especially well. If you have a graph that relates distance and time, so if I've got distance on this axis and time on this axis, it makes sense, even if you're not a calculus student, that your change in distance over your change in time is going to give you your speed or your velocity. So if this is a graph where you're traveling at a constant rate, something like this, that if you find the slope of this graph, you've got change in distance over change in time, which equals your speed, or if you bring direction into it, you've got velocity there. If you've got maybe a more interesting or different kind of a distance time graph, where you've got something that's getting faster and faster, or slower and slower, or doing more varied kind of motion, you might have something like this. And in this situation, you don't have a constant speed. You can't say that the slope of this curve is the same all the way through, but you can find either average velocities or instantaneous velocities. So if I wanted an average velocity or an average speed, I basically would just have to find the rise over run between 2 points. So if, for example, I said, well, between 0, time equals 0, and time equals 3 or 4 hours, what was the average speed? It's just going to be the slope of the secant line. Meaning the slope between those two separate points. So if your car traveled 400 kilometers in total, and it took 4 hours to do that, you'd say, oh, my car average speed was 100 kilometers per hour. And that works perfectly well. But as you can see with this curved graph, the instantaneous velocities during that time were not usually 100 kilometers per hour. It started off really slow, got faster and faster and faster and faster. So instantaneous velocity is something we're a bit more interested in this course, which is going to be the slope of the tangent line to that curve at some instant. So, for example, if I looked at time equals 4, if I have my distance, my time graph, and it's a curve something like this, if I go to 1, 2, 3, 4, and I put a point there, you can't find the slope of a point, but we can find the slope of the tangent to the curve at that point. And that would basically be the equivalent of, clicking a radar gun and saying, how fast are you going right now? And if you take that snapshot of that instantaneous velocity, it's the slope of this tangent line. So it definitely relates to what we did through the last section, 1.4, and even some of the stuff that we did before that. So our first example, which I'll do as a separate next video, is an actual example of something that's traveling, and we'll find some average velocity and some instantaneous velocity.